Explain to me in plain English what they mean by reparameterize the curve with respect to arc length.
They mean like, no. I know what it means, but I can't verbalize.
We have the arc in terms of t time. We want the arc in terms of s arc length. So we need to replace t with some form of s. So we need to link s and t together, right? Once we link them together, we're on our way. Well, we know, what does ds dt equal? Magnitude of r prime of t, right? So the magnitude of r prime, so it's going to be the magnitude of, and we're doing 10 here. Let me just write this down. The magnitude is going to be 2e to the 2t times cosine 2t plus e to the 2t times negative sine 2t times 2, right?
Where does 2 come from?
I had to use the product rule right there. The derivative of the first times the second plus the first times the derivative. Is that correct?
Yeah, that's right.
Yeah. That's only the first component, right?
Yeah.
Nice. Sweet. Okay. Move that over, give it some more space. So that's the first component. What's the second component?
0.
2. Oh, 0. Thank you. Yes. 0. Hey, that's nice. And what's the last one going to be? Oh, great. It's... Yeah, let me make this a little smaller so we can actually fit it in. Yeah. What'd you say? Keep going. Yeah, it doesn't want to go anymore. Okay. So it's going to be 2e to the 2t sine 2t plus e to the 2t times 2, right? Yeah, and what do you need to do to that? You need to take the magnitude of it?
Well, you can plug in 0 because
Not yet. No, we're not plugging in anything yet. What can we do, Shuhan? There's something we can do to simplify this a little bit better. What could we do? Factor out 2e to the 2t. Yeah, because 2e to the 2t is right there, and it's right there. So you end up with 2e to the 2t times cosine 2t minus sine 2t, comma 0, comma, and we can do the same thing here, can't we? 2e to the 2t times sine 2t plus cosine 2t. Well, at least I can almost write it in one line now.
No, I was wondering, just there's no trig.
No, there's no, you really want there to be, don't you?
Yeah.
You want those 2t's to be squares. They're not. You can't do anything about that. Okay, so if we want the magnitude of that, we have to square each component and add them together and take the root of each thing, right?
yeah.
What can you do first?
No, it's easy to calculate.
It is easy to calculate? Yeah, but do I have to? I think I have to write it out once, right? Don't I? Should I write this out? So what do you end up with? 2e to the 2t squared cosine 2t minus sine 2t squared plus 2e to the 2t squared sine. We just started covering logarithmic differentiation in AP Calculus. You might not remember what that is, but the most common mistake in logarithmic differentiation is nothing to do with calculus. It's everything to do with what? Algebra, right? So if we do that, what can we pull out of the front here? 2e to the 2t, right? Times the square root of cosine 2t minus sine 2t squared plus sine 2t plus cosine 2t squared. It's not even the difference. It's going to be, but we need to get there. We're not quite there yet. Point is, there's no difference of squares yet. That's the sum of squares. So there's no nice factorization where things cancel out. What are we going to have to do?
If we take off the
Take off the what?
brackets, the parentheses.
Multiply it
we
out.
get to cancel out.
Yeah, but I'm just saying we have to multiply it out at this point is what I'm saying, right? Yeah, you generally want to try to avoid that, but at this point, is there anything we can do acute factorization? No, you're going to have to multiply it out. Does anybody see anything we can do other than multiply it out at this point? We hope, and as Danny pointed out, it does happen, but we hope if we multiply out something like this and explode it, we hope what happens?
It cancels out.
Lots of canceling. And does it cancel?
Yes.
Yes, it does. We really, really hope that's true. So you get 2e to the 2t times the square root of, what do we get? Cosine squared 2t minus 2 cosine 2t sine 2t. Yeah, hold on. Plus sine squared 2t plus 2 cosine. Ooh, that's not a cosine. 2 cos.
No, it's only sine squared 2t.
Sine, but then you do sine 2t times cosine 2. Ready? This is what I mean. 2 sine 2t cosine 2t plus, I'm just doing the exact same thing, but on this one, cosine squared 2t. What cancels?
Wait, we need one more sine squared.
No, we have sine squared cosine there, and then we have 2 of them right there.
No,
Oh, I missed one over here. Yeah, sorry. Plus, thank you. I'll just put I'm going to put it right here because we're going to write another line here. Sine squared 2t. Thank you. The last from this one, right? Yeah, sorry. So then you have this. Ooh, it has a little bump. Nice. But what cancels out?
That middle one.
That's gone, and that's gone, right? And then you have sine squared 2t, sine squared 2t, cosine squared 2t, and cosine squared 2t. So what does that turn into? It turns into root 2. So let's just take stock. What did we just found? We just found ds dt is, ds dt is 2 root 2 times e to the 2t. Yes.
Doing the same question in the video, you did.
What did we do? We started with this. This was the key to everything right there. We then found the derivative of r of t. We then found the magnitude, and luckily did it come down to something nice? That is awesome, right? We then found ds dt. What did we do to that? We integrated. By integrating, we actually found a relation between s and t, and then we isolated t, and then took what we got and substituted it back into the original equation. So now what do we have? We have where the vector is after a certain arc length. After a certain arc length. A certain arc length from what time? 0. From what time 0? If you're traveling along and you are right here, this right here, let's call this vector right here t of t. That's the unit tangent vector. Let's call it, it doesn't matter if you can use either one, unit tangent vector, right? We also know that spinning off this way, perpendicular to it, if that's t, that can be, what do we want to call that one? Let's call that n of t, the normal unit vector. So that's the unit tangent vector right here, and that's the unit normal vector. Now, if we take the cross of those two things, what do you end up with? You end up with a thing called, what'd you call it? BT. What's that called? Binormal. And this thing, the binormal vector, is perpendicular to both of them, right? I'm trying to draw in 3 dimensions right there. Okay, so the normal plane, which 2 vectors pass through the normal plane?
N and B.
N of t, and B of t, exactly. Did you look up the osculating plane? Which one is the osculating plane?
N and T.
It's the one that passes through nt and t of t, yeah. Nt and, what does osculate, what does oscu mean? Did you remember? It says that in the book. It means kiss, it just touches, right? So if this vector is going like this, the osculating plane is the plane that contains the unit tangent vector and the unit normal vector. The normal plane is the plane that contains the unit normal vector and the binormal vector. Exactly. Now here's the thing. Those are all perpendicular to each other, right? What information do you need in order to write the equation of a plane? You need a point and a normal vector, right? You need a point and a normal vector. So if we find these things at a given point, can we find any plane we want with any combination of these two? Yeah. Let's come up with a name. What would the plane be called that goes through B of t and T of t?
BT.
Okay, if one of them's the osculating plane, the other one's the normal plane, what would the one that goes through T of t and B of t called? What do you want to call that one? not using the same name, a new name. We got to make up a name for it. T of t is the unit tangent vector. So what do you want to call the plane that goes through B of t and T of t? How about the tangent plane? There's your tangent plane, everybody. There's your plane that's tangent. Anyway, it's not really important. We just focus on normal and osculating plane. Okay, so let's actually do some math here. So what's r prime of t going to be on this? It's going to be 6 what? 6 cosine 3t, comma what? 1 comma negative 6 sine 3t. So that right there is r prime of t. So let's find the magnitude of that. If we do the magnitude of that, what are we going to end up with? We're going to end up with the square root of 37 is what I want to say. Is that correct?
Can we just skip that because the direction vector of t is...
Hold on. There are a lot of shortcuts. There's a lot of ways we can go very fast. Let's just do the totally direct method and see what we can cut out, okay? Considering this is the first one we're doing like really as a group, let's do it all and then see what we can eliminate. You're right. There are lots of times here when we don't need to make it a unit vector. All we need is a direction, right? Let's make it unit vectors, okay? Let's just do that for now. It's extra, but you're going to have to do that at some point. So if I do that one, you get the square root of 37. Is that correct? The square root of 37. Nothing.
Wait.
Okay, kids.
Oh, I see.
Does everybody see why it's 37?
Oh, yeah.
36, you get 36 cosine squared, 36, factors out. Okay. So therefore, the unit tangent vector, T of t, is going to be what? 1 over root 37 times 6 cosine 3t, comma 1, comma negative 6 sine 3t. Are we okay with that? Okay, so if we wanted to find n of t, what is n of t equal to? We know that n of t is equal to t prime of t over what? The magnitude of t prime of t, right? So we need to find t prime of t, and when they do these questions in your book, they say we need these ingredients. They just find out r prime, they just do all these things out and then they pull them out. They don't try to evaluate anything. So t prime is going to be 1 over root 37 times what? Negative 18 sine 3t, comma 0, comma negative 18 cosine 3t, right? The magnitude of that, yay! The magnitude of that is going to be 1 over root 37, 1 over root 37 times what? The square root of 18 squared, right? Is that correct? 18, you factor it out. Are we good? Cosine squared plus sine squared is 1, so what do you end up with? 18 over what? Root 37. So now we know that n of t is equal to 18. Sorry, what do you end up with? You're dividing, remember, you're dividing this by this, right? 1 over 18, because the root 37's cancel, times what? Negative 18 sine 3t, comma 0, comma negative 18 cosine 3t. What can we factor out of each thing on the inside of that vector? Negative 18. So you can say that n of t is equal to, how about what? Negative what? Sine 3t, comma cosine 3t. So we now have, just so you know, we have t of t right here. What else do we have? N of t. And now the definition for b of t, what was the definition of b of t? It's the cross t cross what? It's t cross n. That's your strict definition. What happens if you cross n cross t? The other way. It's the exact opposite direction. Still very helpful in this case, but we're doing t cross n. So in this case, what is t? Okay, now at this point, I'm just going to call Schuhan's trick here. Do we really care about the magnitudes if we're trying to find these planes? No, we don't really care about the magnitude because we're only interested in normal vectors, the direction of the normal vector, right? Why am I suddenly don't want to deal with magnitudes? I don't really want to write 1 over root 37 a lot. okay? So is it okay if I just take this vector right here? For our purposes, are we going to actually get b of t? Ready? I'm going to do this. Here, hold on. I'm going to write out the whole thing, and we'll drop it before we do the math here. If you want to cross two things, remember it's 1, 1, 1, and then which one's t? 1 over root 37 times what? What was that first component? 6 cosine 3t. And what was the next one? Was it 1 or 0? It was 1 on this one, right? I think it was 1. And then negative 6 sine 3t. What is it?
It's not 1, it's 1 over root 7. Yeah. 37.
Like that, right? Then what's the last row going to be? Negative sine 3t, right? Ooh. 0. Hey! Negative 0. Negative cosine 3t, right? Okay, so let's finish this up. So that right, if we do this cross right, so first of all, if we're going to find b of t, yeah, it's nasty. That's just, this is as clean as it gets. B of t is equal to 1 times 1 over root 37 times what? Negative cosine 3t, and that's the I, j, or k component. I minus, well, we can say, comma, negative 1 over root 37 6 cosine 3t. Negative cosine 3t, right?
The first one has a negative inside.
The first one has a negative inside.
1 over root.
This one right here?
No, the right way.
Right here?
Yeah.
Yeah, there's a negative there. I have the negative there. It's just floating in space. Do you see the negative right there? That's what you mean, right?
Yeah.
Did I copy that over right from t?
Yeah.
It's I put the negative on the other side of 6.
Yeah.
Well, yeah, ready? How about this? Parentheses.
Yeah.
And parentheses, okay? Is that okay?
Yep.
But what do we have to subtract from this? Ooh, and it's negative of this, remember? Can I just finish writing this? Hold on. I'm going to finish writing this, and then we're going to see, Shuhan, I agree with you that there is a faster, cleaner way to do this. I totally agree with you. Times what? Negative 6 sine 3t, but what do we have to multiply that by? Negative sine 3t. Hey, look, the middle one term, right? So this is I, j, and, hey, at least we have a 0 in this next one, right? So it's minus negative, so it's going to be sine 3t times, what's it going to be?
Plus
Sine 3.
times.
Well, it's this minus that. So it's going to be sine 3t over what? Root 37. Ready? I'm going to simplify it a little bit because I'm running out of space. Sine 3t over what? Root 37k, right? Now, do we see now here's the thing. This is the binormal vector. As far as I remember, and you can answer this question for me conclusively, do they make it the binormal unit vector? No. Here's the thing, everybody. Is this necessarily a unit vector right here?
So why?
No. Hold on. So exactly, we're going to go back to Shuhan's point in a second here. If we wanted to guarantee that this was a unit vector, what would we have to divide by?
Its own magnitude.
Its own magnitude. No.
Do that.
No. So if we're writing, now here's the thing. We're going to go back to what Shuhan said. If we're going back to writing the equations of these planes, let's look at this for a second. We just found t of t, n of t, and b of t. B of t is not necessarily a unit vector, but n of t is a unit vector because it's called the principal unit normal vector. Principal unit normal vector. Why did they say principal? How many normal vectors are there? There's an infinite number. Principal means the primary one, so it's been nominated as primary. Those are unit vectors. So right, I'm going to say this right here. These are unit vectors. Unit vector, and so is this. Unit vector. But what about b of t? Not necessarily a unit vector. Now here's the thing. Do I really care if it's a unit vector to answer this question? No. Did I actually care if the other ones were unit vectors to begin with? No, because we were writing the equations of plane, so we only really need the normal vector, the direction, right? So here's the thing. Let's do the normal plane here. If you need the normal plane, you need the vector that is perpendicular, a vector that is perpendicular to the normal plane. What vector is perpendicular to the normal plane? What's the simplest vector that we have that's right up there? R prime. R prime is in the direction of the unit tangent vector, right? So this right here is this direction right here. That is R prime of t, right? We need a point. How do you get the point? You take the point you take those values and you plug it in. Oh, they just give you the point. You don't have to plug anything in. Hold on. Let's just hold on one sec. Shortcuts in a second. So we have, what's our vector? What's our R prime of t? Anybody remember what it was? Was it negative or positive, Jay?
Positive.
6 cosine 3t? 6 cosine 3t, comma what? 1 comma sine 3t. So there's the perpendicular vector, right? And there's our point right here. So at this point, what would the equation be? Why do we need to solve for t first?
Because you get a number, not the expression.
Exactly. We actually want an actual plane. Do we want t to be in the equation for our actual plane? No, we don't. We absolutely don't. So how do you do that? Well, you know that 0 is equal to 3t. So what's t equal to? T equals 0. So let's just go to the next one and make sure here. Wait, what's the problem here?
Zero equals pi.
Oh, yeah. T equals 2 pi.
Oh, wait, it could be 0 or
2 pi.
or
Pi. Negative 10 pi.
it's actually t is equal to pi n, right? Correct? So would that make sense here? Y is equal to, pi. Okay, that's nice. And then you have negative 2 is equal to 2 cosine 3t. So t is going to be pi. So pi n in this case too. So what time are we at? We're at time equals pi. So what do we do with this? Plug it in right there. So we have r prime. Oh, I just stutter stepped. We have r prime at pi, which is 6 cosine 3 pi over 2, comma 1, comma negative 6 sine 3 pi over 2. Oh, it's just 3 pi. I don't know where I'm getting that. I do not know where I'm getting that 2 from.
What was the previous number of questions again?
Don't remember.
10.
What's cosine of 3 pi?
Negative.
What is it?
Negative 1.
Negative 1. 1 and negative 6. What's sine of 3 pi? Uno, dos, tres. 0. So our perpendicular vector is going to be negative 6, comma 1, comma 0. And our point is 0 pi what? 0 pi negative 2? 0 pi negative 2? Yes, this is recording. Yeah, it's going to be a recording today. Yeah. So what's the equation going to be? Negative 6 times x minus 0 plus 1 times y minus pi plus, minus, so plus 0 times, yeah, I understand, z minus what? Z plus 2, yes, I understand. I'm trying to write the whole thing out. When I don't write in things that are invisible, that are important, it's sometimes hard to see where it goes. I hate using the word obviously. Books that use the word obviously, I don't like them. Luckily, this book I don't think uses the word obviously. That goes away, so you're left with negative 6x plus y minus pi equals 0. There it is. So that right there is the, that's the, what was that? Hold on, wait, let's check. Which one did we use here? We used, that's the normal plane, thank you, yes. That's the normal plane. Because we used r prime as our normal vector, that is the normal plane. Are you okay with figuring out the other one by yourself? Do you understand why the magnitude doesn't matter if we're writing the equation of planes? You just want the direction. How many different ways can you write? Many different ways.
Sure.
Yes.
You're trying to find n.
The curvature as x goes to infinity. So here's the thing, y equals f of x. What do you need to remember? There exists an equation for curvature when y equals f of x, right? From our notes, let's see here, I had it up here somewhere. It's not here, it's down here a little bit. I think I plugged it in, right? Right, oh, it's up a little bit then.
It is
F
only
double
for
prime
two-dimensional.
over.
Yes, it is only for two-dimensional. There it is. Yay. Awesome. Do I really care if you know how to derivate that? Absolutely not. You can read it if you want to, but you just need to know there is an equation for curvature specifically for y equals f of x. So in this case, curvature x is going to be, what's y double prime? Like that, right?
Yeah.
All over 1 plus
Plus x to the negative 2.
1 over 2 squared to the,
Oh, 3 over 2.
and that totally didn't catch all of that, 1 over x squared to the 3 over 2. So what's the top become? X to the negative 2 over 1 plus 1 over 2 the 3 over 2. So first it asks, so there's your curvature, right? That's decent compared to some of the other stuff we've had to put on the board. It's asking where's the curvature maximum? How many times in your calculus life have you found a maximum? Once. Times maybe? Okay, so if you're looking to find a maximum, what are we going to look for? Okay, that's what we're going to do, but what do we... Thank you. We're looking for critical points. Critical points are where the derivative is 0 or undefined. We need to be careful, right? We need to be very, very careful. So what do we need to do to this? Dig the derivative, right?
I tried to
Make it pretty
so
first.
hard, so I just used the calculator.
That's totally fine, Jay. Is that the derivative you got?
That one?
Is that the curvature you got?
Yeah.
Yeah. So if you do this, what rule are you going to have to use at this point? There's no way around this.
Oh, the
You oh,
Ohio rule.
you want to put it up top? So okay, I like this. I just told my are you going to have to use them every day? Yeah. So you could write it like this: x to the negative 2 times 1 plus 1 over x squared to the what power? Yeah, like just yesterday I was telling my AP Calculus kids, avoid using the quotient rule if you can. Can you avoid it? Yeah. So in this case, k prime of x, we're going to have to use the product rule. The derivative of the first, sorry, the pen is being jerky today, 1 plus 1 over the same thing, plus the first times the derivative of the second, 1 plus 1 over x squared to the negative 5 over 2 times what? Times what? Negative 2x to the negative 3. Thank you. Nice. Okay, so here's the thing. Now it's asking you, where does that equal 0, right? And you go, I'm going to use my calculator now. Now, if we got to this point, and said we're going to have to use our calculator, we might as well just take what?
When x equals 0, it would be undefined.
That's true, but we're really, yes, so that would be a possible critical point, but we also need to find out where else could this be 0, right? So here's my question. If we're going to use a calculator at this point, we might as well use the calculator right there, right? If we use that, what can you find from that? You can find maxes and mins, right? You can find maxes. So at this point, use your calculator.
How do you know you got all the critical points?
Look real good.
Like, how do you set the...
Okay, hold on a sec. I'm just really curious as to what the answer book says on this one, so I'm going to look it up. At this point, you analyze that function. At this point, we're going to move on, okay?